Welcome to lesson 7.1. Yes, believe it or not, we are on chapter 7. Our first lesson deals with exponential notation. Big word, but what does it mean? It just means to the power of, or 5 to the third power, which is not 5 times 3, but actually 5 times 5 times 5. How do we identify and compare numbers written in exponential notation? Well, let's find out. Let's get started. Mental math word problems. Prime factorization. Now, you've heard of that before, so let's kind of take a little review. Prime factorization means when you're using the tree and you get it, the tree as in 9 times 3, and we break that down into the smallest it can go. What is the prime factorization of 10? So if I were to draw that tree here, remember I would do a tree like this. Sorry, my pen is kind of going all over. And I have 10 at the top, okay, and I can break that down, okay, into 2 and 5, okay. Now, 2 times 2 would be 4. 4 times 5 would be 20. So I know that one is not right. But I know if I break it down into prime numbers, okay, then I know now that my answer is 2 times 5 because I know they are both prime numbers, okay? So that kind of helps me a little bit. So let's do this and submit. All right, so prime factorization of 6. Again, we break 6 down. We use the tree again. We have 6 at the top. Here's 6. What gives you 6? 2 times 3. Again, I know 2 and 3 are both prime numbers because they don't have any factors that go in them besides them one in themselves. So I would definitely do 2 times 3. Now, there are several of them that can go longer and be broke down more. And I think you kind of remember that as well. But I don't want to spend more time on it. I just wanted to do a little review of prime factorization. So let's go back now to our lesson. And I want to talk a little bit about, oops, sorry, I'm moving my man, and I don't want to move him. I want to, stay there, mister. Okay, sorry. I'm having issues today with this thing to make it work. But now hopefully it'll, why can't I get this to pull out? Darn it. There we go. All right, so prime factorization is finding which prime numbers multiply together to make the original number. So it says here are some examples. Whoops, here we go again with this thing. I'm going to try to move my little friend. Need to click off of that. Okay, now let me see if I can move him. Oh, come on here. I'm having issues, aren't I? All right. All right, so let's see if I can... dang it. All right, well, I'm going to move it down then. And just move it out of the way. So I'm going to move this too down there. I'm going to move my friend over here so we can kind of see it. All right, so it says, example, what are the prime factors of 12? It is best to start working from the smallest prime number, which is 2, so let's check. 12 divided by 2 equals 6. Yes, it is divided evenly by 2 when we have taken the first step. Okay, but 6 is not prime number, so we need to go further. Let's try 2 again. 6 divided by 2 equals 3. Yes, that worked also. And 3 is a prime number. So we have an answer. 12 equals 2 times 2 times 3. Well, and I know that works because 2 times 2 is 4 times 3 is 12. Very good. All right, so let's move this up a little. As you can see, As you can see, let's go back. Every factor is a prime number, so the answer must be right. So as you can see, every factor in that string is prime, so the answer must be right. Note, 12 equals, oops, sorry. I don't know why this is a mess here today, but it is. So we'll see if we can't get it to work here. Oh, shoot. Let's see. All right, let's see if I can get it to go up. Okay, so 12 equals 2 times 2 times 3. It can also be written using exponents as 12 equals 2 to the second power times 3. So that means there are 2 2's. All right, so it's not 2 times 2, but it is 2 2's, which in this case actually kind of does work out. But remember, you're not multiplying or you're not saying 2 times 2 like it is right here. But I'm actually writing 2 times 2. Okay, so let's keep moving. Prime factorization with exponents. Can we show prime factorization as exponents? Absolutely. Let's take a look. What is the prime factorization of 9? So again, if I draw my little tree, okay, I draw this and I have 9. Oops, sorry, that doesn't look so good. I put 9 at the top and I know 3 times 3 is 9. Okay, now again, I have two 3's, they're both prime. So exponential notation would be 3 to the second power. Not 3 times 2, but 3 times 3. Okay, so I would go up here like this, and I would know that this is 3 to the second power. Okay, so hopefully that does make sense to you. All right, let's try one more. What is the prime factorization of 6? And we did 6 before, so we have a tree over here again, a tree, and a tree, and we had 6 at the top, and I know that 2 times 3 is 6, and they're both prime already. So there is no exponents in this case. So I would simply go over here and select 2 times 3, and that would be the correct answer. So there you go. All right. So we're going to move on and keep going with our lesson so we have some more practice. Okay, so on this one it says let's work with numbers and exponential notation. In exponential notation, the exponent tells how many times the base is used as a factor. So the base, for example, 4 to the third, 4 being my base, 4 times 4 times 4. So 4 times 4 is 16. 16 times 4 is 64. The base is 4 and the exponent is 3. The product, 64, is written in standard notation. That means the answer. So exponential notation for this one here with 6 is how many 6's do I have? I have 4, so it would be 6 to the 4th power. My base number is 6. My exponent is 4. Just like that. So then I would multiply 6 times 6 times 6 times 6, or 6 to the 4th power. And a lot of our calculators will do exponents for us now, which is really nice. But if yours doesn't, then, that's okay too. So let's write down the number that I got was 1,296. 2, 9, and 6. Okay? 9 times a 9. Again, exponential notation. 9 to the what power? How many 9's are there? I see 2. So I would put a 2 here. Again, my base is 9. My exponent is 2. So 9 times 9 is 81. Hopefully that makes sense to you. I'd like you to finish those last two for me, okay, and bring those in. Let's go to our last page now. Let's work with numbers and exponential notation. Is there an exponential power key on the calculator? And we did talk about this. It says use your calculator to find standard notation for bases and exponents shown in the table. Record your keystrokes in the third column. So I have 4 times 4 times 4 because my exponent or my base is 4 to the third power. So how can I do that? Now I can do 4 times 4 times 4 and equals, right? And I can get 64. All right. Now on some of our calculators, we will talk about where the exponent key is, and I will actually show you in class. But the keystrokes on this calculator that I have is just 4 times 4 times 4 equals, oops, sorry, I have a 4 here. 4 equals, and then it should be 64, and that would be your answer. Okay, so you can use this calculator, use a calculator you have at home, but please finish up these problems as well. So you have 3 others to do. Now, if you found out how to use your calculator and exponents, please use that, because then it'll show you the keystrokes you need to use for that. So let's go back and just review quickly. How do we identify and compare numbers written exponential notation? And we did talk about that. Okay, we reviewed. You need to finish the last 2 on here, right? The exponential notation, the base, the exponent, and the answer. Some of them are given. Some of you were given the answer in standard notation and the base. And then finally, on our last page, how do we use a calculator? Now, a standard calculator is like the one I just showed you, and that would be you just put it in that many times, however many times the exponent says. And I did 4 times 4 times 4, and it equaled 64. I will show you the keys in class if you don't have a scientific calculator at home. So great job of following along and listening. You have basically 5 problems to bring in. Please make sure you've written those down and do bring them in. And please do the quiz as well. Have a great evening.